So far, we have taught you guys several different ways to predict reactants and products. But now there's three special cases that you're going to have to memorize, and I'm really sorry, there's no other way around them except for pure memorization. So here we go. These are the ones that you're going to have to know. If you have a metal with a carbonate, which is CO3, that's going to decompose into a metal oxide plus a carbon dioxide. If you have a metal with a hydroxide, that's going to decompose into a metal oxide again, and the other product is going to be water. And last, if you have a metal with a chlorate, ClO3, that's going to decompose into a metal chloride plus oxygen gas. So these are just some of the ones that you're going to have to memorize. So what I want to do is I want to do some examples with each one of these. So starting with a carbonate. If you look at number 1 on your green sheet, it says magnesium carbonate, CO3, is heated, which causes it to decompose, and it decomposes into two products. Since it was a carbonate, and we remember that our rule says it decomposes into a metal oxide, so the metal in this case is magnesium. Magnesium has a +2 charge, and oxide has a -2, so when they crisscross, those cancel out. Plus, the other product, when you have a carbonate, is going to be carbon dioxide. So those are the two products, and then after that we have to balance. Well, we have one magnesium and one magnesium. We have one carbon, we have one carbon, and we have 3 oxygens, and we have 1 + 2 gives you 3 oxygens, so that one is balanced. The second example was something with a hydroxide. So if you look at number 6 on the green sheet, number 6 on the green sheet says SN with a hydroxide, and they put a 4 here. When that is heated, it decomposes into some products. Well, we learned from those rules on the first slide that hydroxide is going to decompose into a metal oxide plus water. Well, the metal in this case is going to be tin, and we know that the tin's charge must be a +4 because this came from the charge of the tin. So we'll put a +4 up there. And since it's metal oxide, I'm going to put an O here, and I know that's a -2. When I crisscross, it becomes 2 and 4, which then can reduce to 1 and 2. And then that is added to the second product for hydroxides, which is water. So then in this case, we have to balance. We have 1 tin, 1 tin. We have 4 oxygens, and right now we have 3 oxygens on this side. But let's look at our hydrogens. I have 4 on this side and 2 on this side, so if I put a 2 here, now I have 4, and then I also have 4 oxygens, so that would be balanced. All right, the third special case was going to be the chlorates. So if you look at number 9 on your green sheet, we have magnesium with the ClO3 2. When that is heated, it decomposes into, the special case was metal chloride plus oxygen gas. So the metal in this case is magnesium, and magnesium is a +2. And if you're going to make it with chlorine, then that's going to be Cl, which is a -1, and when they crisscross, it's MgCl2, plus oxygen gas, which is O2 since it's diatomic. So then we have to balance. We have 1 and 1. I have 2 chlorines, and then 2 times 3 is 6 oxygens. And I have 2 oxygens on this side, so we have to put a 3 here to have the even number of oxygens. So now I've shown you an example of all three types that you're going to have to just memorize. The other part of this is that you have to memorize the opposite. So, for another example, let's take a peek at number 11 on the green sheet. Number 11 on the green sheet has SRO plus carbon dioxide. Well, we know that this is going to be synthesis because it says synthesis underneath it. If we go back to our very first slide, anything that was plus carbon dioxide, a metal oxide plus carbon dioxide, we know that it's going to be a metal with CO3. So then we go back to what we said here. Well, our metal was Sr, so the product is going to be SrCO3. And then you have to balance. Well, I have Sr, one Sr, I have 3 oxygens, I have 3 oxygens, I have 1 carbon and 1 carbon, so it's balanced. Let's take a look at number 16 on the green sheet. 16 on the green sheet has another decomposition, which is FeOH3, and that decomposes. So if you have an OH, if you go back to these original ones here, a metal with an OH is going to decompose into a metal oxide plus water. So we know that the metal is iron with a +3, and since it's iron oxide, that's a -2, so we crisscross, it becomes 2, 3, plus water, which is H2O, and then we have to balance. We have 1 Fe on this side, 2 on this side, so I better put a 2 here. I have a lot of oxygens on this side, but let's do hydrogens first. I have 3 times 2 is 6, so I better put a 3 over here to make that 6. And then I have 3 times 2 is 6 oxygens, and I have 3 and 3, so 6 oxygens. So we should be in good shape there. Let's do another one that's a synthesis. If you see number 22 on the green sheet, that's another one with SRO, except this time it's added to water. So if we go back to our original rules, if we have something added to water, that's a metal oxide plus water, we know that the product, if we're going the opposite direction, is going to be a metal with a hydroxide. Well, the metal in this case is Sr, and the hydroxide goes there, and Sr happens to have a charge of 2, so I'm going to crisscross and bring the 2 down, and then we are also balanced in that case. The last one that you have not seen an example of is going to be something with ClO3 as a product, and I don't believe we have any on this worksheet, so it shouldn't be a big deal for you. I hope that this helps with those special cases. The other ones on the green sheet should just be simple single replacement or double replacement or combustion reactions. I should also make sure that you remember for every combustion reaction, you know it's combustion if it has a hydrocarbon, which is some combination of hydrogens and carbons, plus oxygen gas, and your products will always be carbon dioxide and water, no matter what. The hardest part about doing combustion reactions is not knowing the products, since they're always the same. It's more going to be about balancing. So there is a trick to balancing when you get to really high ones. An example of that would be, let's look at number 19. I have C3H6 plus O2. So we know the product's going to be CO2 plus water. When we balance these, I always do it in this order. I always do carbons, then hydrogens, and do oxygens last. I do carbons first because they're the least common, and so they're easy to see right away, whereas hydrogens and oxygens are kind of spread out. And I do oxygens last because we have the opportunity with this O2 to adjust just oxygen, which is kind of nice. So it's easiest to do it in this order. So when I do C3H6, the first thing I look at is I have 3 on this side, so I better put 3 on this side. So now I have 3 carbons over here, and I have 3 over here. I should probably count. I have 6 hydrogens on this side, and I have 2 oxygens. And on this side, I have 2 hydrogens, and I have 3 oxygens right now. Nope, just kidding with this. That makes that I have 6 oxygens on this side. So the next thing that I do then, since my carbons look good, is I'm going to do my hydrogens. I have 6 on this side, so to make this side 6, I have to multiply it by 3. So when I do that, that makes 6, but it also messed up my oxygens. So now I have 6 plus 3 oxygens, so that's a total of 9 oxygens now on this side. Well, this is kind of screwy because I only have 2 on this side, I have 9 on this side, and they don't match very well. If I put a 4 here, then that would be 8, which isn't quite enough. But if I put a 5 here, that would be 10, which is too many. What I really want to do is put a 4.5. Now, you can't really do this, but if you get to the point where you have a 4.5 and everything else is balanced, the trick is you double everything. So let's see if I can change my pen color here. This 1 becomes a 2. This 4.5 becomes a 9. This 3 becomes 6. And this 3 also becomes 6. And now it is perfectly balanced and reduced. It's just a little trick that makes those combustion reactions a lot easier.